Here we go. We have a question: the kth lexicographical string of all happy strings of length n. A happy string is a string that consists only a, b or c, and the current character should be different from next character. For example, abc, ac, b and this all are happy strings, and a, so in this continuous character are there, so this is not valid. Continuous character are there, in this continuous character are there, so this is not valid. We have given n and k. We need to create string, a happy string of length n, and if we sort it according to lexicographical order, we need to find kth string from it. So of length n, so in this test case we need to create happy strings of length 1. So these are 3 happy strings, and in this is our third happy string, this is our kth. Then if we need to find fourth, we only have 3 strings of length 1, so fourth is not possible. We need to return empty. In this example, we need to create happy strings of length 3. These strings are of length 3, and in this we need to return ninth. So ninth will be CAB. This is our answer. I will pick this example and explain to you how this will work. Let's code this. Let's build the approach. So on our first level, we need to start. We can either start from A, we can either start from B, we can either start from C. In this, can we start from A? No, this path is not valid. We cannot again put A. So A path is not valid. Can we put B? Yes, we can put B. Can we put C? Yes, we can put C. Then this is not valid. Then can we put A? Yes. Can we put B? Yes. Can we put C? A, B, C, yes. Then here, can we put A? Can we put B? Can we put C? No, we cannot put C. So this path is not valid. One more thing, this path is also not valid. I just realized. Then from here, can we place B? Can we place C? Yes. Here, can we place A? No, we cannot place A after that. So this path is not valid. Can we place B? BAB is valid. BAC is valid. We need to find ninth. How many strings have we found till now? 1, 2, 3, 4, 5, 6, only 6. Then from here, can we place A? BCA. Can we place B? Yes. Can we place C? No, we cannot place C. This is not valid. So we have found 2 more. So let me mark it. 1, 2, 3, 4, 5, 6, 7, 8. And next, we can put A, we can put B, we cannot put C. From here, can we put A? CAA. CAA is not valid. So cross. Then can we put B? CAB is valid. Can we put C? CAC is valid. But we don't need to go further. This is our ninth string. So this is our ninth string. This is our answer, cab. So how we gonna use this? So we have a solve function. How we gonna implement this? So we have a solve function, solve, and I will pass an empty string, and also, yeah, that's it. then on every level we can either start from A, we can either start from B, we can either start from C. So if previous character we have string, we can easily find out what the previous character is. If previous character not equal to A, so we can go ahead with A, solve with n minus 1, and this is my string, let's say current. So current plus A, and if the previous character is A, we need to put B, then previous character is A, we cannot put A again, so that's why we have to put B. If previous character not equal to B, so then we can put B, solve n minus 1 string we need to find more, then current plus, then we can put B. If B is already there, we can put C, and everything else will be same. For C, if previous character not equal to C, then we can put n minus 1 and current plus C not equal to C. If this is equal to C, we need to find next character, so C next will be A. So that's how it will work, and we can easily find out, using this method we can easily find out what our kth string will be. Let's code this. So we have a solve function, and let me take a global k. This dot k will be global k. Then what we need n, we need string, and that's it. And that's it. We can also create a global answer. Our answer is empty. If we don't have kth string, we need to return empty, so that's why I have taken empty. Void solve length n, and this is my current string, current. If current length, so we can find like this. If we have made the length, then we need to decrement our k. If k is 0, so we are on to a recursive path. If we have reached our destination or the leaf node, so we have placed n number of elements in our current. We have placed n number of elements, so this is a valid string. So then if this is a valid string, we need to find kth. So on every valid means happy string, we are decrementing our k. If our k becomes 0, then we will store our answer. Answer is current. That's it. Then we can place it. If previous character not equal to A, so there are two methods. We can either pick the current last character, or I think the easier way will be to take a new argument named current previous. So if previous not equal to A, initially our previous is empty, means we can either place A, we can either place B, we can either place C. So we have all three options open. So if previous character not equal to A, then we can place A. So solve n, place A, and as we have placed A, so previous character will become A. And yes, if previous character not equal to A, we can place A, we need to so before that we need to create three options, one for A, one for B, and one for C. We need to create three options. How are we gonna create it? So we can put A, n, current plus A and A. We can put B and B. Don't worry, we gonna apply the condition and see if previous character not equal to a, then and only then put place this. If previous character not equal to b, previous character not equal to b, if previous character not equal to c, then we can place c also. So I hope this will work. Let me run this. Cannot find current new string, so string string, and it is giving me an error. Yes, we don't need space. Yes, this is working. Let me submit it. Yes, so we have submitted this code. Let's talk about time and space complexity. So here we have three different options. So three, then only we have two different options on every level. We have two different options, so it will be 2 raised to power n. So it is 3 and 2 raised to power n. Why 3? Because we have three options, so it will be 2 n, 2 raised to power n. And what about the depth? We are not using any space, but we are utilizing we are using recursive space, recursive stack. So how many items it will store? It will store n items. So this is my time complexity, and this is my space complexity. And I hope you have learned something new. Give this video a thumbs up. I will provide you the code in the description box. Thank you all for watching this video.